Welcome to my talk about, or with the topic, test your test suite, or to be more specific, test your test suite with mutation testing in Pest PHP. Now, a little bit about me. I'm from Switzerland, as you can hear from my accent. I have a family. I work as a tech lead full stack developer at Trenda. I'm the creator, or the co-creator together with Nuno of the OpenAI client for Laravel and PHP, and I'm a member of the Pest core team. But why mutation testing? In the first place, it was because of a discussion I had with Philip a bit more than a year ago. I wasn't aware about the concept of mutation testing. We didn't talk about mutation testing, but something similar. So I started a little research there, and I stumbled about the concept of mutation testing. And I don't know, who of you is familiar with mutation testing in PHP? Two of you. Good. So I stumbled out about this concept, then I stumbled about Infection PHP. This is the standard library for mutation testing in PHP, but I wasn't very happy with it. So I tried to do something more in the Pest way, so to make the life for the developers as easy as possible. So the reason why I started this project is because I want to have it only for me. And I had some goals in mind. It should be easy to start with, it should be intuitive to use, and it should be fast. Because this, as we will see later, performance is a problem with mutation testing. So it didn't turn out too bad, and I hope I can convince some of you today to give mutation testing at least a try. But before we can start, we need some common ground. Imagine we have a company, it's called Laravel. They start selling their first product. It's obviously Laravel Pint. And as we live in a modern world, not everybody drinks alcohol. So they have another beer called Laravel Zero. Now, what we focus on today is a little bit of the application logic. We don't want to sell alcoholic drinks to a minor. In Switzerland, it would be allowed from starting from 16 years, but we stick to the 18 years here for today. So we start with a fresh Laravel application, and what I did beforehand is I created a drinks model or the drinks table. They have two relevant columns for us. It's the name, and to simplify everything, there's only a Boolean to indicate if the drink contains alcohol or not. Then on the users table, I added a single field, the date of birth, to store the birthday of the user. Now, when we work with Laravel to implement this business logic, we have multiple places where we can do this, but the most common approach, I would say, is to create a policy. And as this is a talk about testing, we start with a test. We do it in a TDD way, test-driven development. And obviously, we are using a pest test. But as Ruslan already said in the beginning, pest is essentially a wrapper around PHPUnit, so PHPUnit would work as well here. But back to Pest PHP. In our test, we want to ensure that a minor is not allowed to buy an alcoholic drink. So what we do first is we create a user, and we give the user an age of 10 years. Then we create a drink in a database. The drink contains alcohol. And then we expect that the user can, or when we call the can method on the user model with the ability buy and passing in the drink, we would expect that it will return false. So with the first test written, we are going to our drink policy, or we are creating a drink policy, adding the buy method, accepting a user and a drink. And the most straightforward way to make our test green is to just return false. Then we are going back to our test suite, copy the test, and change the test to an adult can buy alcohol. What we need to change here is we need to to change the age to 25, and we expect down here that it will return true. Back in our policy, we accept or we load the date of birth of the user, calculate how many years it's between the date of birth and now, and then compare to the number 18 if it's greater or equal to 18. So I know it's very simple until here, but it's very important to have a common ground for the mutation testing later on. Now, the last thing we are doing, we copy the test again and we check if all users are able to buy a drink without alcohol, because there shouldn't be any age restriction. So we change the drink to not contain alcohol and, oh, sorry, too fast. And we still expect that this will return true. Back in our policy, we can add an early return. If the drink does not contain alcohol, everyone is allowed. So, as we worked with TDD, and we have this drink policy is very simple. And when we take a look, we can see it's simple, it's understandable, and I think it's pretty robust so far. So, but one thing I want to show is with the testing. When we are going to the terminal, no, I don't. Oh, sorry, you can't see the terminal now. When you are going to the terminal, you are in the folder of the Laravel project. We can run pest. This is my shortcut for vendor bin pest, and add the coverage flag to get some code coverage report. Here we can see we have the 3 tests we built before, and as we would expect, they all 3 pass, and we have a code coverage of 100% because we worked with TDD. So it would be surprising if it wasn't that way at all. Now, in PHP Storm, we have this test here, or the test file with the 3 tests we have seen before. What we can do now, we could skip the first test. When we run pest once again, we can see that the first test has been skipped, but our code coverage is still at 100%. So why is this the case? The reason is that the test 1 and test 2, when we are going into our policy, they both test the same path in our application code. So the code coverage is still at 100%, but we all agree the test suite is now worse than before when we disable one of the tests, because all of them have a reason to be here. Where is my presentation? Here. So, oops. So what does this line coverage mean? It means, or what does this 100% mean? It means that we have 100% line coverage. Every line of our application is hit by at least one of the tests. And this is exactly what has happened. So when we skipped one of the tests, we still have 100% line coverage. So is this a good metric? Oops, sorry. I would say no, it's not a good metric. We need a better metric because it doesn't tell us something about the quality of, sorry, I messed up my first and second demo. This is why I'm confused with the slides. No, I wouldn't say it isn't a good metric because it only tells us something about the quantity of the lines that are covered and not about the quality of the test suite. So we need a better metric, and there is where mutation testing comes into play. And for me, at least, this is where the fun part starts. So here's the basic concept of mutation testing. Mutation testing takes your application code and modifies your application code. It mutates the code. And important here, it's the application code. It does not mutate your test suite, it mutates your real application code. And it tries to do it in a way to introduce a bug or an error into your application code. And then it runs the test suite, and a good test suite should be able to detect the bug introduced before. Now, when we go back to PHP Storm, we can do this by hand. For example, we could return false instead of true. And when we run pest again, of course, one of the tests will fail. So our test suite was able to detect this bug in our code. Something else a mutation testing framework can do is remove the early return statement entirely. Once again, run our test suite, and surprisingly, all our tests pass. Does anybody know why this has happened? I lied a bit with the TDD. If I had worked exactly strictly with TDD, I would have seen this error before. But yeah, the reason is here in the search test, we are checking if all users are able to buy a drink without alcohol. But we tested this with an adult. And an adult is always allowed to buy a drink with alcohol. So it doesn't matter if we have an early return before or not. So when we change this user to be a minor and run the test suite again, one of our tests will fail. So mutating our application code helped us to find a weakness in our test suite. Now, mutating the test by hand is very, very boring and too time consuming. And this is where a mutation testing framework can help us. Now, how does a mutation testing framework actually works? First, it runs the initial test suite. So you need a passing test suite to start with mutation testing. And it applies filters to make it more performant, what we are going to talk about at the end of the talk. And it executes the test suite with a code coverage report used later on. Then it first checks if all tests have passed, and if not, it immediately stops and returns the normal test output because it cannot work without a passing test suite. Then it goes through your application code, tries to find possible mutations in the code, apply filters there as well for performance reasons, does some caching for performance reasons as well. And then it checks if it was able to perform at least one mutation in your application code. If not, it stops and tells you that it was not able to find any possible mutations. But normally it does, and then it takes one of the mutations it found, not all of them, only one. Then it looks into the code coverage report, checks if there is a test that covered or hit the lines, a line or lines that were mutated. So for example, removing the early return statement, it checks if on exactly this line, one of the tests or which tests came to hit this line, and then it only executes the tests there. If it cannot find any tests covering the line mutated, it immediately stops there for this mutation and marks it as not covered. Then it checks if there are more mutations, and if so, it takes the next one. And once again, checks if it has covering tests, and if so, it mutates the application code. So it takes the file, modifies the file, and then it runs all the tests covering this line against the mutated application. When they have run, it checks if all the tests have passed, and if all of them have passed, this is bad, because this is what happened before. We removed the early return statement, but the test suite still passed. So in this case, it marks the mutation as escaped. In the other case, if not all of the tests pass, it marks the mutation as caught because it was able to detect the error in the application. If you are familiar with the concept of mutation testing, most mutation testing frameworks call this killed, but I think it's a bit confusing because killed is normally a bad, something bad, but it's actually what we want to have. We want the system to detect. So I went with the term caught instead of killed here. Yes, and this loops once again and again until it has no more mutations left. And then it summarizes or shows a nice summary and calculates a new score. Now, here we talked about finding the mutations. To find mutations, we need mutators. Every mutator in the framework is responsible for exactly one kind of a change. In the library, there are at the moment over 200 of these mutators. And to do this, to perform these mutations, it uses the abstract syntax tree. If you're not familiar with the abstract syntax tree, Marcel gave a great talk at the last Laracana EU, so not AU, EU. So you should check out this talk from him. For example, here in our drink policy, what we did, we removed the early return. So this is the remove early return mutator. Or something else the system can mutate, for example, is changing an operator, changing it from greater or equal to greater. Or change it to smaller. So as you can see, there are many, many changes you can do only in these few lines of code here. Now, our next demo, we are using the Pest plugin Mutate. This is a plugin for Pest PHP. You have to install it on top of Pest. Here we are using the version 2 as beta because the stable release will be together with Pest v3 next week at Laracon US. Oh, I'm here about the demo. What we can do when we have installed the plugin, we can run Pest with the mutate flag, and to keep it a little bit smaller here, we pass in the class we want to mutate, and this is the drink policy class. Now, it happens a lot, but what we can see here, it first runs the initial test suite. As we would expect, the 3 tests have passed. Then it generates 9 mutations in one file. One file because we limited it to the drink policy class. And then we can see it created these 9 mutations on which line, which mutators were applied, and if they have been caught or if they have escaped. And when we go down to the bottom, we can see from the 9, 4 have escaped and 5 were caught. So we have this new score from around 55%. You can already see 55% is much less than 100% line coverage. Now, when we go up again, we can see here the details of the escaped mutations. You can see the line number, which mutator it was, and you have a nice diff, what has changed in your application code. So the one here, we can see here is the one we did before manually. We already know how we can fix this one. We have to change the age of the third test to a minor. Running the mutation testing again, we can already see we only have 3 escaped mutants and the score has increased to 66%. Now, we still have 3 that have escaped and they are all on line 16. So one of them is we changed the greater or equal to greater. We changed the or it changed the age from 18 to 17, or it changed the age to 19. This is something quite common you can detect with mutation testing. We are missing some tests for the boundaries. So when we have written our tests, we used the age 10 and 25. So when we change the value from 18 to 17, the test suite is not able to detect this. What we can do, we could modify our tests, or we can add, we can add another test. In Pest PHP, this with is a function for data sets. We can run the test 3 times with different parameters. So the age of 17 and 18 and 19, and what we would expect here as the output. When we run this test here, run the test, we can see this is behind the scenes, it's converted into 3 tests and they all pass. Running the mutation testing again, we can now see that the quality of the test suite has improved, and now all the 9 mutations got caught, and we have a score of 100%. So this is not too bad. We were able to improve the quality so far, but something that's a bit bad is the duration. It took already 1.7 seconds, but we only had performed mutation testing on a really small class or small file. But what we can do, we can, for example, run it in parallel to make it faster. So now it uses all the power of my notebook, and it reduced it to 0.3 seconds. But I don't want to type parallel all the time, so I can go into the pest.php file, which is the configuration file of Pest besides PHPUnit.xml. And we can configure mutation testing here to use parallel test, always use parallel execution. So when we run it again without the flag, now it runs quite fast. We talked a lot about the escaped mutants or mutations that have escaped. Most of the time, you have to improve your test suite. Normally, your application code is fine, but your test suite is not perfect or not good enough. But sometimes we are able to find some stuff we should do in our real application code. For example, remove unnecessary or redundant code, or we have the wrong visibility, or public instead of protected. And sometimes there are false positives. So sometimes a mutation is performed that changes the code, but the logic is still the same. But this is a rare case, and I personally never hit it yet. And there are many more cases, but these are the most common reasons why a mutation escapes. Now, I have prepared a little other demo to see this. We have an update drink action. And the update drink action, it accepts a drink, a new name, and a boolean to indicate if it contains alcohol. Then it takes all the 3 parameters, pass them into a new function called update drink, takes the drink, calls update, passes in the name in a trimmed version, a string trimmed version, and passes the property, the alcohol property, and then it calls save on the drink. As experienced Laravel developers, you already can see that it's not the best code I have ever written. But we have a test for this as well. And this test is passing as well. Now, we can run mutation testing on this class or this with this test on this class. And I'm too lazy to type everything in the command line. So we can call mutate here, pass in the class we want to test. And the behavior is similar like when you would pass only here. In Pest, when you add only to a test, only this test runs when you run the whole test suite. When we add mutate to a test file, it only runs the tests within this file and takes care of all the configuration we provided here. So in the terminal, we can run Pest without any options, and it automatically starts mutation testing. Only one test has passed, or only one test was run because there is only one test in the file, and it created mutations for one file. Now we can see 4 of them have escaped, which is really bad, and we want to take a look at them. The first one, it removed the method call. It removed the drink save here. So you probably all know that when we call update, Eloquent behind the scene already calls save on the model. So it's redundant to call save here again. So that's something mutation testing is able to detect. So we can safely remove this save here. Next one, it modifies the visibility of the function from public to protected. Here, it's pointless to have a method, but the intention probably was not to make this one public. So it's an invocable action, so this one should be protected. If it's intentional that it's public, you need a test explicitly for this method, because public methods are your API that you are exposing to other classes, project, team members, whatever. So make sure you have a test here, but in this case, we want to change it to protected. Next, it removed the trim statement around the name. Probably it's intentional to have trim here. We want to trim the name, so we should update in this case our test. We pass in the name with a white space at the end and expect that the space has been removed. And last but not least, it removes the alcohol key from the update array, because our test does not check for it. So we need to check if the contains I'm not able to type to be false. And first we have to ensure that it is true, otherwise it makes no sense. Check if the test still pass, perfect. And when we are running mutation testing now, we can see that we have reached a score of 100%. But the mutations have been reduced from 8 to 6 because 2 mutations were not possible anymore. Removing the save statement is not possible because we have removed it from the code, and changing the visibility from public to protected isn't possible anymore because it's already protected. So as you can see, sometimes you have to update your test suite, sometimes it helps you to improve your application. Mutant states. We talked about escaped, not covered, and caught, but there are 2 more. One is the pending. When you are using an option like bail, where it stops when the first mutant has escaped, there is an indication how many mutations are pending or not executed yet. And the last one is timeout. Sometimes it can happen that the mutation in your application code will introduce a loop that never stops. And the framework is clever enough to stop the test execution and mark the mutation as timed out. It's similar to code because it breaks your application, and you will not push this this change accidentally to production because your test suite will fail anyway. Now, we have to talk about performance. As you already could see, it's slow. It's slow because if you have a large application, there are thousands and thousands and thousands of possible mutations. So, but the framework does its best to make it as fast as possible. It uses the code coverage report to only run the covering tests. It caches the mutation, so it does not have to parse the abstract syntax tree again and again. And you can run the mutations in parallel. But much more important, it's what you can do to make it performant. So only run the relevant tests, as we saw before with the mutate in the test file, where we limited the set of tests to a given test file. Mutate only a single class and not the whole application. Normally, you're working on one class or one file. You can pass class file, you can pass the path to a folder, and then it mutates all the files in a folder. There are options to mutate only the change code. So there's a flag uncommitted only when you're working on a new feature. Or there is another option, changed only, which is the diff to another branch, normally the main. This is very helpful when you're going to review a PR. Then it only mutates on the changes that were made by one of your colleagues. And there are more options like bail or retry. Retry is to reorder the tests that, or reorder the mutations that have escaped in the previous run are run first. It's similar to the retry option on Pest itself. Yeah, there are many more options. So if you're interested, check out the docs. Roadmap of this plugin. The beta has been released in June this year. It works with Pest v2. You can already install it, test it out. There is nothing this should break your test suite or your test or your application, because if you don't pass the mutate option to Pest, it does simply nothing. And next week at Laracon US, Pest v3 will be released, and this is the time when the first stable version of this plugin will be released. This one is then Pest v3 only, because Pest v3 gives us some more options. For example, appending mutate directly on a test and not only in a test file. So like we can add append skip to a test, we can then append mutate to a test. Yeah, and during this time, I hope for some feedback and contributions. And surprisingly for me, there are already more than 10,000 installation of this plugin, but only 2 bugs were reported. So I don't know if the people are have installed it and have not used it, or if it's more or less bug-free, or it's too bad and they stopped working. I really don't know. Yep. Before I answer your questions, I have one that I want to answer by myself. Is this a wraparound Infection PHP? As I said in the beginning, Infection PHP is this library for mutation testing in PHP so far. And sadly, it's no. The reason for that is it works quite differently. It makes the same behind the scenes, basically, but it works with PHP spec or plain PHPUnit and so on. And I want to have it tightly integrated into Pest PHP, and this wouldn't have been possible with Infection PHP. So I decided to create a new framework. Yeah. Thank you very much. If you want to follow me, you find me on socials. I have a little website with a blog that I never update. Here is the link to the repository, and I wish you all happy testing.